Now we're going to practice. All right, let's use these rules. So first we want to find the derivative of f of x equals 2 over 3x squared. I'm going to let you do this on your own, but I'm going to give you a hint that we can rewrite the original function as 2/3 x to the negative second, right? Okay, pause the video, find the derivative, unpause when you're ready to check. Okay, so we do our general power rule. Bring the negative 2 down, so I have 2/3 times negative 2 times x to the negative third, because then when I subtract 1 from negative 2, I get negative 3, right? And then I just want to simplify a little bit, because that's kind of a weird way to leave my answer. So negative 2 times 2/3 is actually negative 4/3, and because this is x to the negative 3, I want to bring that back down to the denominator, so I can write it as x cubed. So I get f prime of x is negative 4 over 3x cubed. So remember first semester when I said it's really important that we know all of our rules of our exponents. This came up in our log unit. Now we really need to know those. Next one. Same thing. Find the derivative of g of x equals the fourth root of x. I will give you a hint again. I would recommend rewriting this using your properties of exponents, but this time I'm going to let you try to remember that. Pause the video, unpause when you're ready to check. Okay, so here we should end up with g prime of x is 1 over 4x to the 3/4, or we can write that as 1 over 4 times the fourth root of x cubed. Either of these would be acceptable. How do we get that though? First, I rewrote g of x as x to the 1/4, and so then I know g prime of x, bring down the exponent, 1/4 times x, subtract 1, 1/4 minus 1 is negative 3/4, and then I just rewrite it. Next one. Here we're going to use another application. So finding the equation of a tangent line, we want to find the equation of a tangent line at x equals 1 to this function. So we first want to find the derivative, then find the equation of a tangent line, but this time we don't have to use the limit definition. Pause the video, unpause when you're ready to check. Okay, so the first thing I did was I found f of 1, because I know that if I need to find the equation of a tangent line, I need a point, and right now I just have an x value. So f of 1 is 2. And then I found the derivative. I use my power rule, bring down the 5, subtract 1, I get 5x to the 4th. Bring down the 2, multiply it by 3, I get negative 6, x to the 1st, and the derivative of a constant is 0. So my derivative is 5x to the 4th minus 6x. Then I want to find the slope at 1, so I plug in 1, because remember this represents the slope anywhere at any x value. Plug in 1 though, and I end up with negative 1. So now I know a slope and a point. So I can write the equation of my line in point slope form. Y minus 2 equals negative 1 times the quantity x minus 1. Or I could rearrange it to slope intercept form. Y equals negative x plus 3. Either is correct. Alright, now I want you to try and find an equation for the horizontal tangent line to f of x equals x squared plus 2x minus 8. We've done this before. You don't have to use the limit definition this time. Pause the video, unpause when you're ready to check. Okay, so here we should get the equation of the horizontal tangent line is y equals negative 9. It should just be y equals a number because a horizontal line has a slope of 0. How do we come up with that? First we find the derivative. So I know f prime of x is 2x plus 2 using my power rules. Now, the derivative is the slope everywhere, right? Well, I need the slope to equal 0 if it's going to be a horizontal tangent line. So I set the derivative equal to 0, and I solve for x to find where that occurs. I get x equals negative 1. Now, I plug that back into the function, because again, I know that my equation of a horizontal line is always y equals a number, so I really need to find the y value of where the horizontal tangent line occurs. So when I plug in negative 1, I get negative 9. So that's how I come up with y equals negative 9. I do want to point out, this is something we did last semester as well, because in this case especially, this is a quadratic. So I know that the horizontal tangent line is going to occur at the vertex. I know how to find the vertex of a quadratic because I know it's opposite of b over 2a. And then f of opposite of b over 2a. So opposite of b over 2a gives me negative 1, and then if I plug that in, I get negative 9. So that's another way to think about this. Remember, this all ties together. It all comes back to the circle of life. Next one, similar to what we did 2 examples ago, find an equation for the tangent line at x equals 2 of the function. Pause the video, unpause when you're ready to check. Alright, so we should end up with y minus 7 equals negative 2 times the quantity x minus 2. How did we get that? Okay, well first I found f of 2 because I need the y value, and I got that to be 7. Then I found the derivative, f prime of x is 2x minus 6 by using my power rule. Then I found the slope when x is 2 by plugging 2 into the derivative. That gave me negative 2. So now I have a slope and a point, so I write the equation of my line. Okay, so we have seen and used now our general power rule, our constant rule, our product and our product by a constant, and our addition and subtraction rules. They are incredibly important. Make sure you know them. And again, really it's the power rule. The rest should hopefully just be kind of common sense, hopefully. By common sense, I mean if you understand derivatives, then it's common sense. If you don't understand the derivative, it makes no sense.